for today is going to be functions. Now, functions are an important program structure, but they can also be a little bit confusing sometimes. So this is probably one of the first things where it may not be immediately obvious why this is important, but I assure you that this is important in fact. So coming to the thinking of what these functions and the rest of the program structures are. So 2 weeks ago I think I showed this picture right here. So basically, in all programming languages, the basic building blocks are always the same. So that's a neat way of making things easy for programmers, so that if you happen to know programming in one language, let's say Python, then it's relatively easy for you to migrate to some other programming language. And as an example, let's say something like Java or C#. There happens to be probably thousands of programming languages, so the example is just the first two programming languages besides Python that I happen to think of right now. So we have, well, anyway, of these building blocks, we have already looked at a lot of this stuff, and basically the only things that are left are functions and objects on this list, and then there are something called abstract and compound data types. So it turns out this last point, these abstract and compound data types, are already a bit more advanced things. So these come in a few weeks' time. But basically, all in all, once we have gone through functions, then we have almost all the basic building blocks, and I would say probably important building blocks for making basic programs anyway. Okay, so there was a question, in fact. So is there at any point some example solutions to the exercises? Some exercises already have an example, a sample solution, which you will be able to see once you have completed the exercise. For certain exercises, there is no sample solution, but for most of them there should be. Besides that, there really is no example solutions, at least ones that are handed out. So while some of the tasks do have a sample solution that you can view, it's only one of the many solutions. So I mean you could solve the same problem in many ways. So that's probably why it doesn't make sense to look at sample solutions. It would probably make more sense for you to try to solve the problem the best way that you can think of the solution, because programming really does not work in a way where there is only one solution and you copy the samples and learn that way. That is really not how it works. So it makes sense to build the solutions for your own. So programming is best learned by programming. So even if your solution was not much like the one you see in the examples, that's all right, because you are working toward solving the same problems, and if we get to the same outcome anyway, does it really matter how you solve the problem? But that said, yes, there are some example solutions in the tasks. They are inbuilt, and if there is none, then the task, then the exercise happens to be something where I wasn't really confident that putting a example solution for it would actually benefit any learning. So in case it's a simple exercise where you cannot really go wrong by reading this, the example solution, then there is one, but sometimes there isn't one. Okay, moving on. So yeah, we have covered a lot of these during the last few weeks, and this week the topic is about functions. Okay, so if we remember back to what the conditionals were. So conditional statements were the program structures that you can use to alter the sequence of execution in the program. That's the most important thing here. So rather than having every single line of code be run every single time you run it, we have a little bit of logic involved in the program. So that was the idea with conditionals. Loops, on the other hand, were used for repetition. So if you had some task that repeats, you can automate that repetition using a loop. And if we remember from last week, while loops are used when we have some kind of condition similar to the if statement, where you can say that we should repeat some action until until this condition becomes untrue. So for example, in human terms, you would say something like while something, then we do something, and that's what you can use that's what you can see in the syntax as well. For, on the other hand, was used for going through a collection of things, and that was the thing about Python. In Python, the for loops works a little bit differently to other languages. So if you then go program in some other language later on, or if you have come from another language, this is a thing that is different. So basically, for example, for might be used to go through a range of numbers. And in Python, we also looked at this range function last time. So for example, saying range from 0 to 11 gives us the first the digits from 0 to 10. And then we simply say for I in range, I is a variable that gets assigned a value, and then we can use I inside this loop structure. Okay, so those are the things that we know already. So conditionals for altering the path in which your code takes, and loops are for repetition. So the next important control structure is related to the conditionals and loops, because, well, it's similar yet slightly different. So this control structure, of course, the function. Now, functions are a really easy concept in the way that we have already used them, and actually we have used them a lot. We just didn't explicitly call them functions. So we have been using functions, we just didn't know about it yet. So what is a function? Well, for example, print is a function. Input is also a function. Int and float are functions, so is round and range. And pretty much all the commands, we have been calling them commands from up until now. All these commands, a command in Python that does something is always a function. Something to note, not everything that we have seen is a function, however. So for example, while, or for, or if, or elif, or else, or true or false, or something like a variable assignment, variable name equals something. None of these are functions. So only those commands that result in some action is what we call a function. All of this in this listing, they are respectively not functions. So it's good to understand what it is that we're talking about. So to demonstrate how functions really work, I mean, I already said that, for example, print is a function and input is a function. So what's the big deal? We have already been using them. Well, here when we talk about functions, it's what we're talking about is constructing functions of our own. So writing our own functions. And what the functions that we might be writing are good for, well, we might take an example. So let's say we had this kind of example code which simulates a zoo, a animal sanctuary, if you like. So if we if I just pull up this code on the editor, here we are. So I'm just gonna copy paste the example. Here you can see there's quite a lot, the lines are quite long, so it doesn't even show properly here. But anyway, so how this program works, if I run it just once, so what it does, it just asks us some name of animal species. Let's start with a lion, and depending what name we give, we print out different instructions for the zookeepers. So if we start with the lion, then for obviously lions live in a cage. So in this zoo simulator program now, we're taking care of the animals, so we're gonna do some tidying up, so we will be sweeping the cages. If we were to select some other animal, such as a dolphin, then dolphin obviously does not live in a cage. A dolphin needs some water to live in, so instead of sweeping the cages, we're gonna be cleaning the aquarium. So this is not a very complicated example. So for tigers and lions, they obviously live in cages, therefore we need to clean the cages. As you can see here, the dolphin lives in an aquarium. We could also, the zoo is also inhabited by some people, so there's also zookeepers. And what zookeepers really need, well, probably they just consume a lot of coffee. So if we were to interact with these humans in the zoo, then the action here is brewing a new pot of coffee. That's basically what this example does. Okay, so that's the code. So these 12 lines of code is what this example consists of. Okay, going back to the presentation here. So what we can see from this is a lot of this code is actually basically just repeating the same thing. So we can see there is this if statement here. So we're looking at is this whatever we typed into this variable species. Is it a tiger? No. Then the logic is the same for a lion. We need to do this if else logic here. But we're just doing the same thing over and over again. We're doing the comparison the same way every single time. And also a lot of the text is also the same, especially with these two animals, the tiger and the lion. So for these, the action is actually the same. It says we'll be sweeping the cages next. It's exactly the same for both. So, well, this is a lot of repetition. So hang on, we talked about repetition last time. So aren't loops for repeating things? If you need to repeat stuff, just use a loop. Could we make this code less complicated, or, well, in this case, shorter by using a loop? Well, because there is also this if-else logic, this depending on what the animal species happens to be, it turns out that no, we can't. We can't because there's also some of those changes depending on the user input. So since there is user input, well, what if weren't conditional statements the way to solve varying user input? But that's already what the code is doing. So this all seems a little complicated for what it is. So how can it take, well, okay, this is a short example and it's not that much code, but let's imagine it was a bigger, better program in all ways. So maybe there is a better way, maybe there is some other control structure that combines these ideas. How would we repeat things and also make the logic vary depending a little bit on the user input? So let's try to combine this somehow, these high-level ideas, having to repeat stuff and also having user input, which alters the way the program works. So this is the high-level idea behind functions. So what a function actually does, it allows us to take a piece of code that's designed to perform some well-defined task. So we take a little piece of code that does something very specific. And the idea here is then once we have written a function once, we can reuse it to do the same thing in all the places where that functionality is needed. And this is actually a way in programming terms to abstract some functionality away beneath some common name. Now, how this would work in practice, if we were to alter this program, we might this cage cleaning, for instance, for tigers and lions. If you remember this line, the actual action was completely the same for both of these animals. So we might abstract away this cage cleaning into its own function. And the way to do that is we call a function here in the main program. And then we also have to define that particular function somewhere else. That's done like this. So there is a def keyword followed by a function name parentheses and a colon. And then everything that belongs in the body of this function is indented. So if we go back to our example code to modify this a little bit, we can actually see how this works in action before going into the specifics of how the functions work. So I'm going to start out by defining this action, this thing we want to do, which was to clean some cages in this zoo. What we wanted to do was simply to print we will be sweeping the cages next. And actually, since now we are defining a function that does this particular action very well, we should put some more content into it. So let's make this action actually have some more text. And finally, let's have this this function also printing out when we are done with it. Okay, so that's three lines of print inside this newly created function. Now, the next thing we can do is simply remove the old functionality from these from the old code. I'm actually, for just clarity's sake, going to move the rest of the code away a little bit as well. So I'm just commenting it out. And here inside this if else, we're going to have to use this function now. Now that the function exists, we also have to use it. Well, we don't have to use it, but in order for the function to do something, we have to actually use it at some point. So now, if I run the program, you can see that this new functionality for lions and tigers result in the command here running this function that we defined. And now this way, we don't actually have to write whatever functionality we had inside this if else. We simply replace it with this function call here, and then we write whatever code is necessary inside this function. That's the general idea, but we should look a bit further on how this works. So indeed, the function is defined by using the def keyword. The def stands for defining a function, followed by some name that you decide to give to the function. So you can basically name the function pretty much anything. Something that depicts what the function actually does is always a good idea. And it's followed by brackets and a colon at the end of the line. These brackets have a special meaning. So in the first few lessons, we mentioned that commands in the Python programming language always have these brackets at the end. So what the brackets actually do, they denote a function. So whenever you're seeing brackets, it means that there is actually a function behind that command. In layman terms, we could say that the brackets just mean that something will happen, or this will trigger a certain function in the program. So we could say, if we wanted to give a definition to what a function is, that the function is a command that accomplishes some predetermined action. So that's how you define the function. That's how you write the body of it right here. And of course, as I pointed out in the example, later you also have to invoke the function. So you actually have to use the function's name followed by the brackets. So this is when you are actually using it. This function definition on its own doesn't do anything. So even if you define a function like this, it normally does not do anything. So in order for this to do something, you have to invoke it later on. This is why this line is at the leftmost edge of the code, because we are no longer inside this function definition here. Another point for these functions. So if you remember how the print function works, so basically by saying print and giving it some text within the parentheses or brackets, it will then print whatever that text was. And as you may have figured out by now, you can also place whatever you have, whatever text you want to print, inside a variable and just pass that variable to print as well. So you could do the same thing either way here. Printing hello world could be done with either of these ways. So it turns out this text hello world in this first example and the variable text in the next one, these are called parameters that the function takes. Now this variable or that text is special in the way that it's a way for us to feed data to the function. So if we want to give our function some data, we put something in these parentheses. For printing stuff, it's whatever the text that we want to print. Input also uses a parameter. For input, it's the prompt that we want to show when we are asking the user a question. And for other functions, this of course varies a little bit. So in our animal or zoo simulator, we might do something like this. So let's add one parameter to our example. So I'm going to add this parameter animal inside this clean cage function. Now this will make some changes to the code. And the most visible change is probably if I try to run this now, it will run up to a certain point. So it will ask us a name for our animals. But when I then press enter, we're going to get an error because it's saying our clean cage function is missing one argument, one parameter is missing. So because we added something here, we added a parameter in this function definition here, we should also be putting something inside these parentheses here. So let's pass this species variable, whatever the user typed in. So this is a neat thing to remember. So if there is something within the parentheses in the function definition here, that also means that you should put something in the parentheses here when you are actually calling the function. If one of these has something in the parentheses and the other one is empty, then you are doing something wrong. So always, if there is something within these parentheses, there should also be something within these parentheses. So now we are passing, anyway, we are passing some data. We are passing this species variable into this function. So we are now passing whatever we got from input to our function. So let's make use of this data. So now inside this function here, we have a new variable called animal. So let's add this to the printing here. So let's just make this print. We will be sweeping whatever the animal name was. So it's going to, for example, for lion, it's going to be, we will be sweeping lion cages next. Or for tigers, we will be sweeping tiger cages next. So let's see if it works. So lion is the first. So we can see it's now saying, as we typed in lion, it's saying we will be sweeping the lion cages next. Let's try it again with the other animal. We will be sweeping tiger cages next. So as promised, there is now a little bit of repetition. that happens here. So this functionality for both these animal species is exactly the same, but a little different, because this printout here, here it says lion, here it says tiger. The printout is still slightly different. So somehow we have managed to I don't know if we have solved the issues that we started to think about, but at least we are making some progress. So that is basically what a function parameter is, a way to bring some data into this function from our main program. Something maybe else to remember, we could also try to pass multiple parameters into a function. And this is done by putting multiple values or multiple variables inside this function call, and just separating, and also the function definition, and just separating them with a comma. And this is why, using the print, this is why you can print multiple things if your things are separated with the comma. So as an example of this, we might do just a plain function, something like that. So let's get rid of the zoo simulator for a brief moment. Okay, so just for clarity's sake, let's just see how this example would work. So there were 3 parameters, P1, P2, and P3, and we want to do something with them. Since this line is almost the same, I'm just gonna copy it real quick. P2 and P3. Okay, here is the function definition. And let me move it up a little bit here. So yeah, so this is now what I have typed into the code editor. This is all the code that exists. So as I promised earlier, if I just do this function definition here, so we have defined a new function and it has three different parameters. If I just define a function here and then I try to run this code, well, it will run the code, but the code doesn't do anything. So indeed, you do have to also invoke this function somehow. So I'm just gonna put some numeric parameters, again separated with the comma, to this function call. And now when I run it, it prints the values of our function parameters right there. Okay, so that's for using multiple function parameters. So parameters are a way to pass data into a function. So if there is a way to pass data to the function, there probably is also a way to retrieve data from the function, so getting data back. And well, actually, we have already seen how this works because we have been using the input function. We have been using function so long that we haven't really stopped to think of how it works. So this is basically this is how it works part right now. So in the input function, when we ask for input like this, we always have to have this variable and variable assignment here to place whatever it was that the user typed into this variable, and here variable is just called name. if we're asking the user for their name. So name is a variable in which we are storing data that came from this input function. And this data is something that's called a return value for the function. So in programming terms, we say that input has some return value. And in order to use that return value, we must place it into a function. We must place it into a variable like this. So if we are getting a return value from a function, we must place it inside a variable, and that's what we are actually doing here by saying name equals something. And in this case, what we are assigning to this variable name is whatever the input function returns. So this is how we have been using it with input already. How how does returning values work with the functions that we have written for ourselves? So you can basically return any type of data from a function. It can be a number, it can be text, or it could be a truth value like true or false. So for example, and that's done by using the return keyword or return command followed by some data. So for example, if we have a function here called meaning of life, and it may have some lines of code here. Here, in the example, it just has one line saying return the value 42. Just to see how that works in practice again. So let's write this function instead here. So it was meaning of life, and this function takes no parameters, so we are not passing any data into the function. However, we want to retrieve data from the function. And well, here could be more lines of code, and basically we just want to return the value of 42. And much like the previous example, if I just save this here and run this function, run this code, again, nothing happens because I have not actually I have not invoked this function yet. So again, what I must do is I must invoke it like this. Because this function now has a return value, it's slightly more complicated. So just invoking it like this, if I run it again, the code will run, but again, it does nothing. So now we also have to catch this return value that this meaning of life function is trying to give to us. And of course, to do that, we do the same thing that we were doing with input. So so we have to assign the return value from this function to some variable, and I'm just going to call this variable number because this meaning of life function returns a number, and that's my logic. And later on we can actually use this for something, for example, like this. So again, we have some variable that's assigned some value, and that value comes from this function meaning of life. And how this function meaning of life works, this is determined by this function definition right here. So everything all the way down to this return, and what puts this value 42 into this number variable, it's this return statement right here. Now if I run the code, now it will actually do something. So you can say meaning of life 42. Using the return values require that you have some variable in which you store the return data from the function, like I showed. So here is another example. I'm not going to type this out because it's actually in the on the lesson page in Learn, so you can just copy it from there and see how it works. But what this example is trying to outline is basically that indeed we must have some variable name here that is assigned whatever value this function returns for us. So if we have a return value, we must store it in some variable. Otherwise, the return value from the function doesn't get stored anywhere. So all you have to remember is it works exactly the same way as how input works. We say some variable name equals sign, then your input function, and whatever the input function returned is stored into that variable. And this function call works exactly the same way. So whatever is in this example returned by this maximum function is assigned to this largest value variable. Okay, so in these examples, I don't think it has become really clear why these parameters and return values actually exist. So what we could do instead of having parameters and return values, we could do something like this. So I'm actually going to type this example now down again because this is rather important. So let's say we have here some variable that contains data. So let's say we have this number, and this number is the meaning of life according to the Hitchhiker's Guide to the Galaxy book. So, and here meaning of life 42. Then if we had some function, if we wanted to, and I'm gonna say this example is something that you're not supposed to do. If this is the only example that you get from today, then things have gone wrong. So this is what not to do. But this is part of the why do we need those parameters and return values. So what we could do inside this function, now that we have some variable here that exists, we could simply just use that variable inside this function that's aptly named function. And later on, if we invoke this function to actually make it do something, we could see that it indeed prints this value. So, and it doesn't matter that this line of code, this number is here. We could also place it here below this function definition and run it again, and the code will still work. Now, this is something one could do, but it is not a good practice. This is not a good idea. And actually on this course, you are really not allowed to do that. The problem here is this program, this code now that I just demonstrated is 4 lines long. There are 4 lines of code. Well, imagine you were working with a program that has much more lines of code. Maybe there was 100,000 or 200,000 lines of code in this program. Now, imagine all the rest of the code was between this line here, number equals 42, and this function definition. So in here was 100,000 lines of other code. So then it's not, you couldn't really possibly see here when you come to this function here where this variable number has come from. Now, I am not saying this is like a thing that you that is illegal or anything. It's perfectly legal, and actually this has some uses, but in practice this is probably never a good idea. So using variables like this is strongly discouraged. So instead, we should do something like this. So when we define a function, if we need some values or some data inside it, we should bring them in as parameters to the function like this. And then later on, when we actually use the function, we pass that data into this function call. So so instead of doing this, what we actually should do is do this. So now this function has a parameter, one parameter called number, and this parameter I could either pass the value here in the function call, saying, okay, function and call it with this value 42. And if I run it, it will work. I can also assign this value to some variable and then just pass on this variable as well. This will work equally well. This is more or less how things are supposed to work. In this example, we had three different parameters. There were A, B, and C, and what the print did was say that the values A, B, and C, and then later on when we invoke these, we might have some variables in the rest of the program here. So like, let's say x is 1, y is 2, and z is 3. And when we are calling or invoking this function, we then pass on these parameters accordingly, like this. And there are very good reasons why this is the preferred style of doing things. There is a slight difference to what these different variables are and how they handle. So actually there is a little bit of a mistake in this code now. So that's supposed to be x, that's supposed to be y, and this is supposed to be z. And the same thing repeats on this following slide as well, x, y, z. Okay. So here, what's highlighted in red, these A, B, and C, these are variables that exist with this function that's aptly named function again. So these are what are called local variables. They exist within the function only. Well, actually, they start existing when this function is invoked. So when you call the function here, that's when these variables start to exist. So A, B, and C do not exist until we actually use them for something. It's said that these variables belong in the same namespace. And that's the namespace of this function. And namespace is a rather important concept. But for now, let's not get bogged down too much on what it is. The namespace simply means the surrounding function in which these variables live in, and these variables live in within this function. So this function is their namespace. Okay, so that's all for A, B, and C. Then we had this X, Y, and Z. And the reason why I typed in X, Y, and Z here is just to illustrate that these are indeed different, not only different variables, but also different types of variables. So hang on, here should also be X, Y, Z. Well, actually, it does not matter, but so here the X, Y, and Z are what are known as global variables. These global variables exist everywhere. That's because they are used here and defined here in the main program level. So they are defined here on the same level as where this function definition is. So everything that belongs inside a function is of course indented to the right like this. And it's said that this function's namespace is within whatever is within this indentation. But X, Y, and Z, on the other hand, these do not belong into a namespace of any function. So that's why they are called global. And what global means is that these variables are actually they exist everywhere. Literally, they exist everywhere, also inside this function. And that's how you could use them within this function. But using X, Y, and Z directly within this function, again, is a really bad idea. It's really discouraged to do that. And this is why instead we should do something like this. Just as a reminder, using a variable like that, so we had this example where we just have a variable, it has some value inside, and we are using that inside a function. So using a variable like that to pass data between namespaces is what is commonly known as using a global variable. So because the scope of this variable is what we call global, we could use it inside a function. And this, when we do that, we say that we would be using a global variable. That's what a global variable means. Oftentimes, using a global variable, however, really is a bad idea. And that's why this practice is really discouraged. Okay, I think, if I'm not mistaken, that this is the last slide in the PowerPoint. I think I am correct as well. So that means we have reached the end of the presentation, so I'm going to turn off the recording at this point.